Today, we're diving deep, literally, into the sensory world of one of the ocean's most incredible animals. We're not just talking about whistles and clicks for communication. We're going to explore how dolphins use sound to build a vibrant, ridiculously detailed picture of their world. It's a process so advanced, it's basically like seeing with sound. So let me just ask you this to start. Imagine you have to navigate a world where light is almost useless, a place that's murky, deep, and often in total pitch-black darkness. How would you find your next meal? How would you spot a predator coming? I mean, this is the challenge dolphins deal with every single day.
And this is why evolution came up with such a brilliant solution. You see, in water, light is just terrible. It fades out after just a few meters, it scatters all over the place, it's totally unreliable. But sound? Oh, sound is an absolute superstar in the water. It travels for miles, it moves 4 times faster than in air, and it can carry incredibly precise information. The ocean isn't a visual world, it's an acoustic one.
Okay, so to be the master of this acoustic world, dolphins evolved this amazing biological toolkit. And this isn't just about making random noises. We're talking about a highly specialized set of anatomical hardware. Let's break down the 3 key parts that let a dolphin paint a high-def picture using nothing but sound waves.
First up, you've got this thing called the melon. No, not the fruit. It's this fatty organ right in the dolphin's forehead, and it's basically a biological acoustic lens. Its job is to take the sounds the dolphin makes and focus them into this tight, controllable beam. Think of it like a sonic flashlight they can aim with pinpoint accuracy.
So, where do the clicks actually come from? You'd probably guess their vocal cords, right? But nope. Instead, dolphins force air across these things called phonic lips right near their blowhole, making them vibrate. That's what produces the rapid-fire clicks. And by controlling the airflow, they can adjust the frequency and the power of those clicks on the fly.
And here is where it gets absolutely wild. How do they hear the echoes coming back? It's not through their ears, not the ones on the outside anyway. The sound is actually picked up by their lower jaw. It's hollow and filled with these fatty channels that are perfect acoustic conduits, funneling the returning sound waves straight to their inner ear. They literally hear with their chin. It's amazing.
All right, so we've got the hardware down, but the real magic, the part that's just mind-bending, is in the processing. See, dolphins don't just hear a simple ping coming back. Their brain takes all this raw data from the sound waves and builds what scientists can only describe as an acoustic hologram, a complete, 3-dimensional mental image of an object.
So let's walk through how this hologram actually gets built. It all starts with that focused click from the melon. Now, when that click hits something, let's say it's a fish, it doesn't just bounce back as one single echo. No way. Instead, hundreds of tiny micro-echoes come flying back, and each one is packed with different information about the fish's size, its shape, its texture, even what's inside it. And the dolphin's brain just puts it all together into a full 3D image all in real time.
This quote just nails it perfectly. It's not about one single data point. It's this rich, layered tapestry of information. Every single pulse, every burst of clicks adds another layer of detail, building this complex, volumetric hologram inside the dolphin's mind.
Now, this ability to create acoustic holograms gives dolphins what you can only really call sensory superpowers. I mean it. They can perceive things about their world that are completely invisible to us, going way, way beyond what our eyes could ever hope to see. And the detail they get is just staggering. Experiments have shown that dolphins can tell the difference between materials like metal, plastic, and wood based on sound alone. They can identify complex shapes, they can sense the texture and density of an object, and they can even find things that are completely buried under the sand. But maybe the most stunning thing of all is that they can see the internal structure of other animals. Yeah, think about that for a second. It's like having a built-in medical ultrasound machine. They can actually see the bones, the lungs, the organs inside another living creature. It's probably why trainers have noticed that dolphins seem really fascinated by pregnant women. They can likely perceive the developing fetus. And what's more, they have conscious control over this. When they are just kind of scanning the area, they use slower, more spaced-out clicks. That's their wide-angle lens. But when they lock onto prey, they switch to what scientists call a terminal buzz. We're talking a rapid-fire burst of hundreds of clicks per second. That's their macro lens, giving them an incredibly high-resolution image right before they go in for the catch.
So this isn't just some cool party trick, you know? This unique way of sensing the world fundamentally shapes a dolphin's mind, its intelligence, and its entire experience of what reality is. The cognitive implications here are just profound.
I mean, to handle this constant fire hose of complex acoustic data, the dolphin brain had to evolve in a very specific way. Their auditory cortex, the part of the brain that deals with sound, is absolutely massive, way more complex than ours. It's all dedicated to this one incredible task, turning simple echoes into a holographic world. And this leads to a pretty mind-blowing, though still speculative, idea. What if they can share these images? Some scientists theorize that dolphins might be able to encode these acoustic holograms into their vocalizations, basically sending a mental picture from one dolphin to another. Can you imagine? Instead of using words to describe a fish, you just send the actual sensory data of the fish.
This suggests a form of consciousness that is just fundamentally different from ours. When we remember something, it's often a visual snapshot. But for a dolphin, a memory might be a collection of acoustic reflections, a rich volumetric data file. Their whole concept of reality, of space and objects, isn't built from light, it's built from sound.
And really, that's the question that leaves you reeling. We can understand the biology, the physics, the mechanics of it all, but can we ever truly wrap our heads around what it's like to live in a world made not of sights but of echoes? To think not in pictures but in sound-generated holograms? It's a glimpse into a type of intelligence that is both deeply familiar and at the same time completely and wonderfully alien.